Welcome back, everyone. Today, we're diving into something really cool, open source physics at Singapore. OSP at SG for short.
Catchy, right?
Definitely is. And it's not just a name. This project actually snagged a Goldie Energy Award.
That's right, and those are pretty prestigious.
So we've got some digging to do. We've got a blog post about OSP at SG, and we've got the project website itself.
Let's see what made this project so award-worthy.
Yeah, what's the secret sauce? What are we going to uncover in this deep dive?
Well, for starters, maybe we should explain what the Energy Awards even are.
Good point. Not everyone might know.
These awards are given out by Singapore's Ministry of Education.
Like they're top honors for education projects.
Exactly. They're specifically looking for innovative projects.
Okay, so OSP at SG won one of these in 2016.
And not just any Energy Award, the Gold D
Yeah.
at the headquarters division level.
Wow, so the stakes were high.
It's a pretty serious accolade.
So this isn't just some science fair volcano.
No, definitely not. This project is way more than baking soda and vinegar.
So spill the beans. What makes this project such a big deal?
Well, imagine over 100 interactive physics simulations.
Wow, 100. That's a lot.
And get this, they cover topics from O-level to A-level physics.
Okay, so that's like high school level, right?
Basically, yeah. From introductory physics all the way to more advanced stuff.
But I'm guessing it's not just the quantity, right? There's got to be something special about these simulations.
You're catching on. It's not just about how many, it's how they're made.
Okay, I'm intrigued. What makes them stand out?
For one, they're built using HTML5, which means anyone can access them.
No special software downloads?
Yep.
Oop.
Just open a web browser and you're good to go. Plus, and this is a big one, they were all developed by educators.
So not by some big tech company?
Nope. This project was a labor of love by teachers for teachers.
Wow, that's dedication.
Right. It shows how passionate these educators were about making physics engaging.
I mean, creating one simulation is impressive, but 100, that's a huge undertaking.
And it doesn't stop there. They've also got over 100 Java Tracker video analysis resources.
What are those exactly?
Imagine analyzing how objects move in videos. It's a really hands-on way to learn physics.
Oh, so students could use this to analyze real-world scenarios, not just textbook examples.
Exactly. It bridges the gap between theory and reality. They even have 2 ebooks on advanced physics topics.
So it really covers the whole spectrum, from the basics to more complex concepts.
They really went all out. It's impressive.
But I'm still curious about this mathematical modeling thing they talk about. What's that all about?
That's one of the things that really sets this project apart.
So it's not just about memorizing formulas and plugging in numbers.
No, it's about going beyond the surface level.
Okay, so how do they actually encourage this mathematical modeling within the simulations? Can you give us an example?
Absolutely. Let's take the block sliding on an inclined plane simulation. They can change the angle, the mass of the block, even add friction.
So like a virtual lab experiment.
Exactly. And by playing around with these variables, students can figure out the relationship between them and the block's motion.
Ah, so it's about discovering those underlying principles, not just applying them blindly.
Got it. It's a more active and engaging way to learn physics.
Now, you mentioned this project was driven by educators. Do we know anything about the masterminds behind it?
The blog post mentions a project leader. They call him Leongster.
Leongster, that's cool. It sounds like they're really passionate about this project.
Definitely. They talk about wanting to make a real difference in education.
It's always inspiring to see teachers going above and beyond like that.
It speaks to the power of passionate educators.
Absolutely. And the fact that all of this is freely available online, that's incredible.
A testament to their dedication to open educational resources.
It's amazing what they've accomplished. Okay, so we've got the awards, we've got the scope of the project, the technology behind it, and even a peek into the minds of the creators.
But we've just scratched the surface. There's so much more to explore.
Like, what exactly are these challenges with educational technology projects that OSP at SG is addressing? I'm all ears.
Well, a lot of times, these projects rely on external vendors to create the resources.
That makes sense, but what's the problem with that?
Well, it can be extensive, for one. Plus, those vendors might not fully understand the educator's vision.
So OSP at SG being entirely teacher-driven, that's a big deal.
It is. It shows that educators can be at the forefront of innovation. They don't have to wait for someone else to create the resources they need.
It's like they took matters into their own hands and said, we can do this ourselves.
Exactly. It's a testament to the power of educator empowerment. They had a need, they had a vision, and they made it happen.
That's a powerful message. And I'm curious, did they have support from the Ministry of Education, or were they going rogue?
It seems like they had support, thankfully. The blog post mentions individuals and even departments within the ministry who helped out.
So it wasn't just a few teachers working in isolation.
Nope, there's a real sense of collaboration and shared purpose.
That's fantastic. It shows that a supportive ecosystem can really make a difference. Now, we've talked about the impact on students, but I imagine creating this project had a huge impact on the teachers themselves, right?
Oh, absolutely. It must have been an incredible learning experience for them.
Imagine the new skills they picked up, the new approaches they discovered.
It's a win-win situation.
And let's not forget the impact on the wider community. Open educational resources mean anyone can benefit from this project.
Exactly. It's all about making high-quality education accessible to everyone.
No barriers, just pure learning.
And it's not a one-way street. Others can use the materials, adapt them, even contribute their own ideas.
It's like this constantly evolving resource growing and improving over time.
It's a beautiful example of the power of open education.
We've covered a lot of ground. The awards, the resources, the tech, the people, even the impact beyond Singapore.
But there's one piece of the puzzle we haven't fully explored yet.
You're talking about this mathematical modeling approach. We touched on it, but I'm ready to dive deeper.
Let's get into the nitty-gritty of how it actually works within the simulations.
Let's do it. So we left off talking about this mathematical modeling and how it sets OSP at SG apart.
It's more than just plugging numbers into formulas, right? It's about really understanding the concepts.
Exactly. Like that block sliding down the incline, students get to tinker with the variables and see what happens.
It's all about those aha moments when they see the connection between the math and the physics.
So they're not just memorizing equations, they're actually seeing how they work in practice.
And it's not just limited to mechanics. OSP at SG covers a wide range of topics.
Okay, so give me another example. How would mathematical modeling work in a different area of physics?
Let's see. How about, the alternating current generator simulation?
Ooh, electricity, always a fun one.
Right. So with this simulation, students can actually manipulate the different parts of a generator.
Like the magnets, the coils, that kind of thing.
You got it. They can change the speed, the magnetic field strength, all sorts of things.
And I bet they can see how those changes affect the output current in real time.
Exactly. It's like they're building their own generator, virtually.
So it's not just reading about it in a textbook, they're getting hands-on, even if it's digital.
And through that process, they start to develop a mathematical model of how a generator works.
Ah, so they're seeing the equations come to life, not just existing on a page.
And it's way more engaging, right? Who wouldn't rather play with a virtual generator than stare at a formula?
Okay, I'm sold. So we've talked about a couple of examples, but how does OSP at SG actually guide students through this whole process?
Well, the simulations are designed to be pretty intuitive. They provide a structure, but also a lot of freedom.
So there's a balance between guidance and letting students explore on their own.
Exactly. It's like a choose-your-own-adventure through the world of physics.
Love that analogy. Each choice leads to a new discovery, a deeper understanding of the concepts.
And speaking of choices, let's talk about the team behind OSP at SG. We know Youngster is the leader, but who else was involved?
Yeah, was it a one-man show or a collaborative effort?
From what the blog post says, it was a real team effort. Youngster worked with a whole group of educators.
So it wasn't just one person's vision, but a shared passion for making physics education better.
Exactly. And that really shines through in the project itself.
You can tell there were a lot of minds coming together, bouncing ideas off each other.
And that's kind of the beauty of teaching in general, right? It's a very collaborative profession.
Teachers are always learning from each other, sharing resources, trying new things.
And OSP at SG takes that to a whole new level with this global network of educators thanks to open source.
Right. Teachers from all over the world can access these resources, adapt them, share their experiences.
It's incredible to think about the reach this project has, breaking down those geographical barriers.
So it's not just about Singapore anymore, it's about impacting physics education worldwide.
And it all comes back to that commitment to open educational resources.
Yeah, it's amazing what can happen when knowledge is freely shared like that.
It's not just about consuming information. It's about contributing to a collective pool of knowledge.
And OSP SG has certainly made a big splash in that pool.
Okay, so we've covered the simulations, the mathematical modeling, the team behind it.
And the ripple effect it's having on the global education scene.
But now I'm curious about the bigger picture, the long-term impact.
Yeah, how has OSP at SG actually changed the way physics is taught, both in Singapore and beyond?
That's the real test of its success, isn't it? Let's explore that next. So we've seen how OSP at SG works, the simulations, the mathematical modeling, all that good stuff. But now I'm curious about the bigger picture.
Yeah, so what? What kind of impact is this project actually having on the world of physics education?
Exactly. Has it really changed the game? I mean, awards are great, but
Right, it's not just about trophies on the shelf.
what evidence do we have that OSP at SG is actually influencing how physics is taught?
Well, winning that Goldie Energy Award definitely sends a message.
It's like a signal to other educators saying, hey, check this out. This is worth your time. Exactly. Plus, OSP at SG has been featured in a bunch of articles and conferences.
So it's getting attention, people are talking about it,
It's generating buzz for sure.
and hopefully inspiring some teachers to adopt these methods in their own classrooms.
Well, the beauty of open educational resources is that anyone can access them.
No gatekeepers, no paywalls, just pure knowledge sharing.
Precisely. A teacher in a small village could be using these same resources as a professor at a top university.
That's amazing. It really levels the playing field.
And it creates this sense of community, too. Educators from all over the world can connect and share ideas.
It's like a global support system for teachers who want to make physics more engaging.
Exactly. So even though we don't have hard data on how many teachers are using OSP at SG,
We can see that it's sparking conversations, inspiring new approaches, and connecting educators worldwide.
is planting seeds, and who knows what will grow from them.
That's a great point. Thinking about the long term, what could this mean for the future of physics education?
Well, if more and more students are learning physics this way, through hands-on exploration and problem solving,
They're more likely to develop a deeper understanding of the subject, right? It's not just rote memorization anymore.
exactly. And that deeper understanding can lead to a greater appreciation for physics.
Instead of seeing it as a scary, confusing subject, they might actually find it exciting.
And who knows? That excitement could lead to more students pursuing STEM careers.
We might have a whole new generation of physicists, engineers, and inventors thanks to projects like OSP at SG.
It's not just about teaching physics, it's about fostering a love of science and a passion for discovery.
And those are qualities that will benefit students no matter what path they choose in life.
Absolutely. We've come a long way in this deep dive, from exploring what makes OSP at SG so special.
Just thinking about its potential to transform physics education around the world.
It's a reminder that innovation can come from anywhere, even a team of passionate teachers in Singapore.
And that open educational resources have the power to break down barriers and empower learners everywhere.
So to all our listeners out there, keep exploring, keep questioning, and keep that spark of curiosity alive.
Because who knows, maybe you'll be the one to create the next award-winning educational project.
The world needs more passionate educators and curious minds like yours.
That's a great note to end on. Thanks for joining us on this incredible journey into the world of open source physics.
It's been a pleasure diving deep with you.
Until next time, keep those minds curious.